Life Cycle Assessment, LCA, is an essential tool for understanding the environmental impact of a bike throughout its entire life cycle. In this presentation, we will delve into the various stages of a bike's life cycle and explore the environmental impacts associated with its production and use. Firstly, let's discuss the raw material extraction phase. The production of bike parts often involves the extraction of materials such as steel, aluminum, and plastic. These processes require significant amounts of energy and resources, contributing to environmental degradation. The extraction and refining of these materials can result in habitat destruction, energy consumption, and water pollution. Moving on to the manufacturing stage. The production process of bikes can also have substantial environmental impacts. Manufacturing facilities consume large amounts of energy and water, leading to carbon emissions and the depletion of natural resources. Furthermore, the use of certain chemicals and solvents in the manufacturing process may pose risks to both workers and the environment if not handled properly. Next, let's consider the transportation phase. Bikes need to be transported from the factory to the retailer or directly to the consumer. This transportation process often involves the burning of fossil fuels, resulting in carbon emissions and air pollution. It is important to explore more sustainable transportation options, such as using renewable energy sources or optimizing logistics to minimize the carbon footprint associated with bike transportation. Now, let's focus on the use phase of a bike's life cycle. The use of a bike by the consumer itself has relatively low to zero carbon emissions compared to other modes of transportation, such as cars or motorcycles. By choosing to ride a bike instead of driving a car, individuals can contribute to reducing greenhouse gas emissions and improving air quality. Encouraging bike usage as an alternative mode of transportation can have significant positive environmental impacts. Lastly, we need to address the end-of-life phase of a bike. Disposal methods for bikes can have both social and environmental impacts. Many bikes end up in landfills, which contribute to waste accumulation and the release of harmful substances into the environment. It is crucial to promote responsible disposal practices and explore recycling options to minimize the environmental impact associated with the disposal of bikes. Initiatives such as bike sharing programs or refurbishing old bikes can help extend the lifespan of bikes and reduce the need for new production. Interpreting life cycle assessment results can be challenging due to the complexity and variability of measurements and assumptions involved. However, these assessments provide valuable insights that enable us to make informed decisions and evaluate alternatives that can lead to reductions in environmental impact. In conclusion, life cycle assessment is a powerful tool for understanding the environmental impacts of bikes and other products. By considering the raw material extraction, manufacturing, transportation, use, and end-of-life phases, we can identify areas for improvement and implement strategies to reduce the environmental footprint of bikes. It is a collective effort involving manufacturers, policymakers, retailers, and consumers to adopt sustainable practices, optimize production processes, and work towards responsible disposal options. Let us all strive to minimize the environmental impact of bikes and create a more sustainable future. Certainly, let's continue exploring the topic of life cycle assessment, LCA, for bikes and its implications on the environment. One important aspect to consider when conducting an LCA is the selection of materials used in bike production. By choosing environmentally friendly and sustainable materials, such as recycled or bio-based materials, we can reduce the environmental impact associated with raw material extraction. Additionally, incorporating design principles that prioritize durability and repairability can extend the lifespan of bikes, reducing the need for frequent replacements and subsequent manufacturing processes. During the manufacturing stage, implementing cleaner production technologies and practices can significantly reduce energy consumption and emissions. This can be achieved through the use of renewable energy sources, adopting energy-efficient manufacturing equipment, and optimizing production processes to minimize waste generation. By embracing sustainable manufacturing practices, we can mitigate the environmental impacts of bike production while improving overall operational efficiency. When it comes to transportation, Minimizing the distance and emissions associated with shipping bikes is crucial. Localization of production facilities and establishing regional supply chains can help reduce the carbon footprint associated with transportation. Moreover, exploring alternative transportation methods, such as rail or sea freight, which have lower emissions compared to traditional road transportation, can further reduce the environmental impact. In terms of the use phase, promoting the adoption of bikes as a sustainable mode of transportation is essential. Encouraging bike commuting and investing in bike infrastructure, such as dedicated lanes and parking facilities, can incentivize individuals to choose bikes over cars, thereby reducing carbon emissions and alleviating traffic congestion. Additionally, educating consumers about proper bike maintenance and providing resources for repairs can prolong the lifespan of bikes, minimizing the need for new purchases. Lastly, addressing the end-of-life phase of bikes is crucial for a truly sustainable life cycle. Implementing proper disposal and recycling practices is essential to minimize waste generation and release of harmful substances into the environment. Working with recycling facilities and organizations that specialize in bike recycling can ensure that valuable materials are recovered and reused, reducing the demand for new raw materials. In conclusion, life cycle assessment is a valuable tool for understanding the environmental impact of bikes throughout their entire life cycle. By considering each stage, from raw material extraction to end-of-life disposal, we can identify opportunities for improvement and implement strategies to reduce the environmental footprint of bikes. It is a collective responsibility to embrace sustainable practices, advocate for policy changes, and make informed choices as manufacturers, retailers, and consumers. By doing so, we can contribute to a more sustainable and environmentally friendly bike industry.